Alright, ladies and gents, this is a short little intro on how to graph rational functions. So we're going to pretty much do everything the same from before, except we're not going to discuss end behavior for these guys. So we're going to start off with finding the x and y intercepts. Okay, and to find x-intercepts, we would set the y equal to 0, because for any x-intercept, y is 0. So we have 0 equals 3x squared minus 12x over x squared minus 2x minus 3. And we want to solve for x. So what I would like to do is I'm going to multiply both sides by what's on the bottom. Okay. Now, 0 times anything is going to be 0. And these would cancel out. I'm left with 0 equals 3x squared minus 12x. We can factor out a 3x out of both those terms. So we have 3x equals 0 and x minus 4 equals 0. So x equals 0 and x equals 4. So those are our x-intercepts. Now for the y-intercept, that's when we set x equals 0. So we have our y equals 3 times 0 squared minus 12 times 0 over 0 squared minus 2 times 0 minus 3. Okay, and that's going to end up being 0. So our y-intercept is 0, 0. Now I'm just going to plot those 2 points, or 3 points I should say, and then we'll be good to go. Okay, so our x-intercept and y-intercept of 0, 0 kind of overlapped, so I just plotted it once, and our intercepts are graphed. Next slide, just because I'm running out of room on this one, we're going to find the intercepts. No, not the intercepts, the asymptotes. Alright, to find the asymptotes for the graph, let's just start with vertical asymptotes, just for a good measure. Vertical asymptotes occurred when the denominator was equal to 0. So we're going to do x squared minus 2x minus 3 equals 0. Now we're going to solve for x. So this guy is factorable. We have x equals 3 and x equals negative 1. So those are vertical asymptotes. So at 3, oops. And at negative 1. Now it's not perfect, but you get the idea. Now I'm going to make them dotted just so we know that's not part of the function. Okay, they're just imaginary lines. Now for horizontal. We want to plot those, we want to make sure the leading exponents are the same, and if they are, we can divide the leading coefficients. So that means, looking at our equation, we have x squared and x squared, so we can assume y is equal to 3 over 1, so y equals 3. That's going to be our horizontal asymptote. Okay, now I'm going to do some test points, because we have all this stuff going on, and we don't really know where our graph's going to be. So, I'm going to make myself some room here. Test points. I want to pick a test point that's in this area. So for anywhere from -1 to -infinity. So I'm just going to pick, say, -3. Then I want to pick some in here. And I'm just going to pick 2. Then I'm going to pick another one on this interval. So I'm just going to pick 6. So when x equals -3, plug that into the equation, and what do we get for our y? Alright, after plugging those points into my calculator, or just doing it by hand, whatever, you'll get 5.25 if you plug in -3 for x. So we're going to go to -3, go to 5.25, right around here, something like that. Okay, we have, so we can assume, since the graph is never going to touch the vertical asymptote, and it's going to get, the curve is going to get infinitely close to the horizontal asymptote, we can assume it looks something like this. Yeah, that was disgusting. Alright, now for the second point we chose 2, and our y value was 4. So we go 2 to 4. And I see how we have one point that's below the horizontal asymptote and one point above. So that means from between these two asymptotes, our graph, our function is going to cross that horizontal asymptote. Yeah, I can do better than that. Definitely get really close to the asymptote. Okay. And then we have one more point that we chose. We chose x equals 6. Our graph, our function came out at 1.7. 6, 1.7 is right about there. Okay. So our function graphed is the lines in green. The red is a vertical asymptote, the blue is the horizontal. Now, if you plug this into the calculator, you would get something very similar to that. Okay. Now, I hope this helped. Bring questions next week, and we'll get through it.